All right, so I just finished like explaining how you take different tests or exams or data and you can standardize it. That's why it's called the standard normal information. All right, so let's look at this example. So the mean score of the ACT is 20.8, standard deviation is 4.8. Mean score of SAT is 1500. Okay, and the standard deviation is 250. If a student takes both tests, scored a 30 on the ACT, 1280 on the SAT, compare on their exams, and if they want to submit the best score to, what should they do? Oh, I didn't finish that thought, but what should they do? All right, so first thing I want to do is just draw the ACT. All right, so I'm going to do ACT black. Yeah, sure. All right, so mean score of 20.8. 1, 2, 3. 1, 2, 3. I'm going to do 20.8 plus 4.8 plus 4.8 plus 4.8. Get my positive 25.6, 30.4, 35.2, 20.8 minus 4.8 minus 4.8 minus 16, 11.2, 6.4. All right, so this is kind of why it's a big deal. If people score like 36, that's top. It's things that happen in the first standard deviation. So from here to here, that's the right there. That's the majority of the data. Things that fall in within 2 standard deviations are rare. And then things that fall in 3 standard deviations are very rare, very unusual. Things that happen outside of that, nearly impossible. It rarely happens. So somebody to get a 36 on the ACT, it rarely happens since it's above 3 standard deviations. All right, let's do SAT. All right, so SAT was 1500. And then 250 was the 3, 0. All right. I hope this is the new one. This would totally be the new one because the old SAT is out of 1600. The new one's not. It's over a different score. All right, and then we're going to minus 250, 250. All right, so here's what we did. Here's a couple of things we know from this data. Okay, remember this is 0. That's 1, 2, 3, negative 1, negative 2, negative 3. So positive 2 standard deviations away from the mean is the exact same as 30.4 on the ACT or 2000 on the SAT. Those are equal scores. Okay, and that happens 95% of the time. I mean, 2 standard deviations are within 95% of the data. For somebody to score a 2000 or a 30.4, they're in the top 5% of the test takers. All right, I want to go to the next page. I'm going to come back to this. Here we are. Let's do the next part. They take both tests. They score a 30 and a 1280. All right, so the formula, remember z-score, was that minus b for standard deviation. Okay, I'm going to do ACT. All right, so our score was 30 minus 20.8 over 4.8. Then the SAT is 1280 minus 1500 over over. Oh, 250. I don't know why. Whatever. All right, let me put this in our calculator. So do this with me. 30 minus 20.8. We get 9.2 divided. All right, we get 1.9. So it's almost 2. 1280 minus 1500 divided by 250. I get negative 0.88. All right, this means that it's almost 2 standard deviations above the mean, so that's an equal sign. This means that it's almost 1 standard deviation below the mean. Right, so I want to go back to up here. Okay. So ACT 30. It was here. This was ACT. SAT. So all I did was I just found 30 on that number line. Okay, and this is 30.4, and so 30 would be right there. Okay, and then SAT 1280. So I'm looking here at these guys. So it's right here. It just must have been a bad test day where they took the SAT before, you know, they had taken a certain math class or something, and so that's why their scores were different. And we calculated negative 1.9 and 0.88. Okay. This is 1.9. This is negative 0.88. All right, and so you can see how they compare, right? And if the student wanted to submit their best score, you're going to submit the one that's almost 2 standard deviations above the mean. This means right here that they're basically in the top 5% of people who score in the SAT. Right? And so if the student wanted to submit the best score, this one's higher, 1.9. This guy is closer to the mean, so it's closer to the average students. When it's closer to 0, it's closer to the mean. And so if they were submitting it, to the college of their choice, they would probably give their ACT score. All right, so the standard normal distribution, I just kind of, had touched on this a little, is that the mean is 0. Okay, each standard deviation is 1, and so when you take all the data with its, mean of whatever 1500, standard deviation of 250, and you put it on there, you're standardizing it, and so you're finding the standard normal distribution, hence another name for it. The z-scores correspond to how many standard deviations away from the mean is. It's a measure of position. Okay, and we use this formula every single time. Sometimes, okay, we'll go with that for right now. All right, and let's round to the 100th. Now, the reason we want to round to the 100th is because later we're going to talk about like percentages, some probability of something happening, and so if not to the 100th, then you 100th and percent. So percent means per 100. So that's the reasoning for that. All right, so there's a thing called the z-table. I want us to look at it. It is located in the course. So notice a couple of things. So right here, those are negative numbers. Here, there are positive numbers. It is not completely is not necessarily equal. So like 0, 0, 0, and 1 is 50, 40. 0 and 1 is 49, 60. Notice though, if you add them up, you get 1. Okay. How do we use this? Well, let's say we were looking at, a z-score of 1.15. I just made it. Okay. So you would come here to 1.1, and this is 0. That's 1, 2, 3, 4, 5. And so a z-score of 1.15 corresponds to 0.8749 decimal, which means it's 87.49% likely to happen. All right, it'll make, to me, in my opinion, a lot more sense once we do some problems. Let me pull up what we were doing. And it's the z table. All right, so right now I just want to practice finding the area, and then we'll kind of like put it into some context later. Oh my gosh, that is so funny. I guess I just subconsciously knew that the number was coming up, 1.15. All right, and so that's what we did. These are the tenths. It goes to the tenths right here. And then this is the hundredths. And so we get that 8749. Let's do another one, negative 0.24. And so we're going to go to -2 and then 0.4. And so we get 40.52. We could also, in our calculator, look over here, push second bars, go to CDF. Okay, this -10,000 is just a blanketed number. Okay, you just picked a really tiny number, and then we wanted the -0.24, and so that's what you get there. Let's go over here. The one we just did up here. Okay, a score of 1.15. Hang on. I want to check something out for y'all. Okay, so if you type in your calculator, okay, so vars right here, guys. We're gonna push second vars, and then go to CDF. I'm just going to type in -1,000 or 10,000, 1, 2, 3, comma, and then the number was 1.15. All right, so that bottom piece is what you're looking at, and then press enter, and we get 0.875, 8749, and that's exactly what we got on the chart. Okay, that -10,000 is just a blanketed number, and so we did normal CDF. We did -2, 3, comma, and then that 1.15, and it will tell you the z-score, which is the exact same as here. Okay, so I hope that I'm showing you this because I want you to understand, the calculator is programmed with the z-chart information and an algorithm. And so if the chart kind of confuses you, you can use the calculator, or you could just use the chart. Either way. All right, so that's how we find just z-score. Now let's figure out like what it means. And so I'm going to do that in the next video.